2 and 2 together, so it's 4. I cannot do much. I'm just going to put these two in front, and e to the x. Sine squared t. And then sine t, cosine t, and then these two. Sine e to sine squared t, and cosine e to sine squared t. I ran out of room. Of course. Good. So let's look at a ratio like that 26. Because I would like you to be able to simplify something like that before we look at applications of this. When do we need a chain rule? What for? Okay, so that was 26. And this is g of y equals y minus 1 to the 4th over, I think it's y squared plus 2y to the 5th. Is it? Okay. I don't read with glasses, and this is too close. I have to take my glasses off to see. Okay. So this is function 1, and this is function 2. So g prime of y, top function prime, 4 y minus 1 to the 3rd power. It happens that y minus 1 prime is 1, times the denominator, minus. Are you okay so far? The top function prime is 4 times y minus 1 times the inner function prime, but that's 1, times y squared plus 2y to the 5th power, minus y minus 1 to the 4th power, and then times 5 times y squared plus 2y to the 4th, and times 2y plus 2 over y squared plus 2y to the 10th. Do we agree with all steps? Except that this has to be here, but I ran out of room. No one is surprised. So, any questions on this? Is this okay? Please do not simplify this with this. I've seen it. That's why I repeat myself like a broken record. Do not simplify these two. This is a piece from a term, and this is a factor. Okay, ready? I will definitely factor out y minus 1 to the 3rd, and I will factor out y squared plus 2y to the 4th power. Do we all agree with those two factors? Okay, very good. So y minus 1 to the 3rd, y squared plus 2y to the 5th, over y squared plus 2y to the 10th, not to the 5th, but to the 4th. Thank you. Thank you. And yes, now you can do this. Because you simplify a factor from the top with a factor from the denominator, to be exact 4 of those. Yes, now you can do that, but not in a sum or a difference. Okay, perfect. So then what is left from the first term? Let's see. 4 is left. This is completely out. And 4 of those are out. 4 y squared plus 2y, and now I reached minus. There is a 5 left. There is a y minus 1 left. And there is a 2y plus 2 left. 2y plus 2. Okay, so now let's continue with y minus 1 to the 3rd. The denominator now is y squared plus 2y to the 6th. And let's see what is left at the top. No problem to distribute here. 4y squared plus 8y. Now, here's how I would like to multiply these 3. I have a y plus 1 here if I factor out a 2. Y plus 1 and y minus 1 is y squared minus 1, and I have to distribute a 10. So negative 10 y squared plus 10. But I'll wait for you to calculate that. So I pulled out the 2 only because it was easier for me to multiply y minus 1 by y plus 1, which is y squared minus 1. And then I have to distribute negative 10. And that's how we get a negative 10 y squared plus 10. Do you agree with this? Do I need to show any intermediate steps? Okay. So finally, we'll simplify in parentheses, and it's done. Y minus 1 to the third. This is negative 6y squared plus 8y plus 10 over y squared plus 2y to the 6th power. My preference is to factor out a negative 2. So I will factor out negative 2, y minus 1 to the third, 3y squared minus 4y minus 5, everything over y squared plus 2y to the 6th. And then you can leave it alone. There's nothing else we can do here. Okay, I would like to look at a word problem. To see why we even discussed this. So let's read this. I'm looking at 84 on page 207. So let's read the problem. It says under certain circumstances, a rumor spreads according to the equation. So they came up with a function. P of t is the proportion of the population that knows the rumor at time t, and a and k are positive constants. Find the limit as t approaches infinity. Find the rate of spread of the rumor. What would that be? The rate of spread. The derivative. Fine. Very good. And then we can graph if you want. We can graph with the graphing calculator. It doesn't matter. But I'm interested in part A and B. And as you see in section 9.4, which we'll not get to, this is part of Calc 3, we will see that this is a reasonable equation for P of t. So, yeah, it's a logistic growth model. Yes. Chapter 9.
Okay.
So we have 6, 7, 8, 9. That's Calc 2. You're right. Correct. Okay, ready? So let's copy the function. So we have, that's problem 84 on page 207. Yeah, I think we start at 10, chapter 10. P of t equals 1 over 1 plus ae raised to negative kt. So P of t is a proportion. So I make myself notes. It's a proportion that knows around time t. So t is time. Okay. Find the limit as t approaches infinity. Limit, that's part A. T approaches infinity. From 1 over 1 plus a e to negative kt. So we have to plug it in and see what the situation, which situation we're facing here. So we are told that a and k are positive constants. Let's make sure it says a and t are positive constants, because it has a huge impact on the answer, especially k. So as t approaches infinity, negative kt will approach negative infinity, because this is a positive constant. T approaches infinity with minus in front, approaches negative infinity. So then we are looking at e raised to negative infinity. Where does this go? Yes, because it's 1 over e to infinity, right? So this is 1 over e to infinity, which approaches 0. So then all this piece with a constant in front, when t approaches infinity, this will approach 0. So what is the limit? Yes, we don't have to do anything. Which means y equals 1 represents a, yes, horizontal asymptote at infinity only. We have not checked anything else. Okay, in part B, they're telling us that they want us to find the rate of change. Define the rate of spread of the rumor. So one more time, P of t is 1 over 1 plus a e to negative kt. It's not a mistake to differentiate a quotient, but every time the numerator is a number, please remember it's easier to differentiate this. To which power? Negative 1. Thank you. It's easier to differentiate this than the ratio. But it's up to you. Maybe this is just my preference, and you'll say, nope, I don't want to use it. You don't have to. That's fine. So P prime, now I have to be careful because I have to bring down negative 1, subtract 1 from the power, and now differentiate the inner function. This function is the inner function. So I have to differentiate the yellow function. So the first portion is 0 plus, so there is no more plus because this is 0, a multiplied by this prime. So e to a function prime equals e to a function times the inner function prime. So this will be e to negative kt multiplied by this piece prime, negative k, times negative k because t prime is 1. Very good. Great job. So now let's clean it up a little bit. Okay. So this has a negative exponent. This has a negative exponent. They will go where they belong. This has a minus, an a, and a minus. So at the top, ak. In the denominator, e to kt, in parentheses, 1 plus a e to negative kt to the second power. And don't try anything else here. Questions on this? Questions? Okay. There is a course on what it's called differential equations. I'm only going to give a very simple example. So first of all, it's an equation, correct? Because it's differential, it's called differential equations, it's because it has derivatives in it. So here's an example on page 206, problem 76. For what values of x does the following function, we're given y equals e to, I think it's rx, satisfy the differential equation, second derivative of y minus 4 times the first derivative of y plus y equals 0. This, it's a differential equation. It has derivatives in it. And the function, right? The second derivative of the function, the first derivative of the function, and the function itself. So the question is asking us one more time. It says, for what values of r does this function satisfy the differential equation, the second derivative minus 4 times this first plus the function equals 0? Okay. Any ideas how to start, what to do with this? What do I have to do? Find y prime. Excellent. Good. So then y prime is multiplied by, very good. So I'm going to write it as r e to rx. Do we all understand this? Good. Now what? The second derivative, very good. So then I have r e to rx times r. So this will be r squared e to rx. Okay, so I have the function, I have the derivative, and I have the second derivative. Now I have to put everything together. Can anyone dictate?
So r squared rx minus 4r rx plus rx.
Good. So the question was asking us to find r such that the equation is fulfilled. What would be our next step? Indeed, since e to rx is a quantity that is never zero, I can simply divide by e to rx even. So then I get r squared minus 4r plus 1 equals 0. It's not factorable. If a quadratic equation is not factorable, what will I think of doing to solve it? Quadratic formula, very good. So this is 4 plus or minus b squared minus 4ac over 2a. Do you need me to write the formula for you as a refresher, or we remember? We know this. Should I write it? Yes? Okay. So here it is. In the case of the equation ax squared plus bx plus c, this is mandatory. Set up like this. In descending order, equal symbol and 0. Only in this case I can write negative b plus or minus b squared minus 4ac over 2a. These go together. If the equation is not presented like this, I cannot use the quadratic formula yet. Okay? So then we have to continue here. So then r equals 4 plus or minus the square root of 12. We know the square root of 12 is 2 the square root of 3. I will factor out the 2 because that's the only way I can simplify it, or separate it into two fractions, the same thing. So 2 plus or minus the square root of 3. These both work. These are the solutions to the equation, r squared minus 4r plus 1. If r is 2 plus or minus the square root of 3, one or the other, the equation is fulfilled. Second derivative minus 4 times the first plus the function equals 0. Any questions? Any questions? We looked at graphs and we read from graphs. Now I would like to use a table to make sure we understand that too. I know you do, but let's look at an example. Please choose either A or B. Okay, so we want to look at A, f of g of x, and find h prime of 1. Very good. So 63 on page 206, and we have h of x equals f of g of x, and we are asked to find h prime of 1. How do we start? What do we have to determine first? The h prime of x. Correct. So let's determine h prime of x first. Can anyone dictate h prime of x? f prime of g of x times, awesome, very good. Now I can find h prime of 1 as being f prime of g of 1. Why do I have two times g prime of 1. So now from the table, let's read the values we need. We need g of 1. G of 1 is 2. Very good. Then we need g prime of 1. G prime of 1 is 6. So this is 2 and this is 6. So then I have f prime of 2 multiplied by 6. So now I want to determine f prime of 2. F prime of 2 is 5. Correct. So this will be 5 times 6, which is 30. Any questions? Any questions? I'm hoping you finished all the web assigned so I can post the grades tonight from chapter 2. That should have been, okay, perfect. So I will do that. I waited for you to finish. Any questions on this? Do we have any questions about the chain rule? Do you think we should work on more problems? Yes, okay, so let's choose the next one. Let's choose. I was going to move on to implicit differentiation, which is also chain rule. But I'll rather go back to anything you want. Page 205. Paul, if you want to choose anything from 7 through 46, feel free. Also, let's find the equation of a tangent line also, 51 through 54. So let's choose 2 more problems.
What about 35?
35 it is. Let's start with 35. Very good. I'm posting the URL so I don't lose it. Okay, so we're looking at 35. And this is on page 205. Let's see, 35. Where are you, 35? I see. So y equals cosine of 1 minus, is it 2x or 3x? I think I see 2x.
Yeah, it's 2x.
And also 2x in the denominator.
Yes.
Okay, perfect. So as you see, cosine is applied to a function, which is a ratio. We are choosing, we have to apply the chain rule, and remember there is only a product in the chain rule. Okay? So I have to differentiate cosine. So I would like, moving forward, every now and then, because I'm going to move on to implicit differentiation, remember y prime is the same thing with dy over dx. So let's use that. First, we have to differentiate the outer function. When we differentiate cosine, what do we get? Negative sine of 1 minus e to 2x over 1 plus e to 2x. But now, multiplied by the inner function prime, which is this prime. So, which is a ratio. The denominator will be 1 plus e to 2x squared. Now we have to be very careful with numerator prime is negative e to 2x times 2 multiplied by the denominator minus the numerator multiplied by the denominator prime. And for once I did not run out of room. So proud of myself. So let's do this one more time because I was kind of fast. Okay, so this is the outer function, this is the inner function. First I have to differentiate cosine and the argument stays. So cosine prime is negative sine of the same argument times, now this is the inner function, I have to differentiate it, but I have to use the quotient rule because it's a quotient. So the denominator has to be squared. The top prime, this is 0, minus e to 2x times the inner function prime. Inner function prime is 2x prime, which is 2. times the denominator, mandatory minus, I copy the numerator, and now I differentiate the denominator. 1 prime is 0, e to 2x prime is e to 2x times 2, times the inner function prime, which is 2. Is this okay? Every step. Of course, we have to work on this because now we have to simplify it. So there is nothing I can do to this. But I see that I can factor out at 2, at e to 2x, and a minus. That will cancel this minus or take care of that. So I'm going to continue here. So I have 2 e to 2x. I'm sorry, I didn't mean to put the equal symbol that low. They all have to be lined up. Okay. So 2 e to 2x sine 1 minus e to 2x over 1 plus e to 2x times, so this is out, sorry, this is out, these two are out, so I have 1 plus e to 2x. These are out, and the minus is out, so plus 1 minus e to 2x over 1 plus e to 2x squared. These two go away, and 2 gets multiplied by this 2, so 4 e to 2x over 1 plus e to 2x squared times sine 1 minus e to 2x over 1 plus e to 2x. And this is final. No one can simplify this any further. See if you have any questions. Because I have 1 plus 1, which is 2, and I put it in front, yeah, multiplying it by 2. Questions, please. Is there another one that we want to look at? Is there another one before we look at implicit differentiation? Is there anything else? I'd like to look at a problem from 51 through 54, please. Do I get to choose, or yes? Okay, in that case, 52. We have y equals the square root of 1 plus x to the third, I see. Is it x to the third?
Yes.
Very good, thank you. Of course it is, because 1 plus x cubed, when I plug in 2, I get 3. Okay, we're asked, find the equation of the tangent line to the curve at a given point. Ready? Okay, so I know y minus y1 equals the slope times x minus x1. I know I have 2 and I have 3, but I don't have the slope. But that's not a big deal, because I will do what? Find? Yes, find dy over dx, or y prime. And remember, this is this situation. So it's going to be 1 over 2, the square root of 1 plus x cubed, times the inner function prime. Very good, awesome, 3x squared. So this will be 3x squared over 2, the square root, 1 plus x cubed. We want to evaluate this function for what value of x? Exactly. So please pay attention to the notation. So because I used intentionally dy over dx, I drew a bar, vertical bar, and I wrote at the bottom x equals 2, which means I'm evaluating the derivative of function y at x equals 2. So this is 3 times 4 divided by 2 times, and we know the answer here is the square root, is the function, right? This was the function, so it must be 3. So 8 plus 1 is 9, so it's 3. Of course, I don't multiply, I simplify, so the answer is 2. So that's good, but it's not good enough. I have to go back and put it in the equation of the tangent line. So then I have y minus 3 equals 2 parentheses x minus 2. So then y minus 3 equals 2 times x minus 2 to x minus 4, but plus 3 is 1. So the equation of the tangent line to the graph of the given function at 2, 3 is y equals 2x minus 1. Any questions? Is this okay? Matt, is this okay? Please, any questions? No, okay. Good. Do you think now I still have about 15 minutes, 10 minutes left? 14 minutes left. Can I start implicit differentiation? Okay. We're not going to be able to finish. We need more problems here. So 3.5, implicit differentiation. What's this? Well, if I give you f of x equals x squared minus 3x plus 1, I'm giving you the function. And if I ask you to find f prime, you will immediately say 2x minus 3. But what if I give you this? And I'm asking you find an expression for dy over dx. First of all, let's talk about this notation one more time. This notation automatically tells us that it tells us that y is a function of x, right? If I'm asked to find dy over dx, it is very clear that y is a function of x. If I'm asked to find dp over dt, what does this mean? Automatically. Exactly. So please always remember that. Perfect. So that's one thing. Now here, I'm asking you to find the expression for dy over dx. If you're going to attempt to solve this equation for y, you're not going to be able to. So that's where implicit differentiation comes into play. I can still find an expression for dy over dx, although there is no way I can solve this for y. So I can find dy over dx not directly, like I did it here, but implicitly or indirectly. Correct. Yes. Because I don't have the function. So I don't have the function, I can't solve this, but I can still find an expression for its derivative. You could say, yeah, right, but that derivative will depend on the function that you don't have. That's true. I agree if you make that comment. Yes, when we are going to find an expression for dy over dx, it will not be clean x in it, but also y. But still we have an expression and we can work with it. If we want to find the equation of the tangent line to a particular point, we still can. So that's the best we can do. So here's how, what is my next concept? If I want to solve the equation, what type of equation is it? A radical equation. Then I will have to do what to both sides?
Square.
Yes. Why am I squaring? Because I want to take care of the square root, right? So I can apply a procedure as long as I apply it to both sides. The same thing here. We are going to differentiate the left-hand side, and we're going to differentiate the right-hand side. When I differentiate the right-hand side, I know exactly what I'm going to get. That is
0.
perfect. So the right-hand side is 0. But now I have to be very careful with the left-hand side. Why? Because I have two products. 1, 2. 1, 2. Y is not a variable. Y is a function that I don't have. So let's differentiate this first product. The first function prime is, yes, that's not a problem, times y cubed plus x multiplied by the second function prime. This is the chain rule. It's a function raised to the third power, so I have 3 times the function to the second power times, exactly. Now many students ask me, forget about dy over dx, just write y prime. It's legitimate, it's fine, you can. I won't, because I know that sometimes when I write, I may disregard that or I don't see it. Who knows? I can come up with something. So it is wise to use dy over dx. Plus, we reached this stage in which we have 2x squared as the first function and we have y as the second function. So please differentiate 2x squared.
4.
Very good. So it is 4x times y plus 2x squared times dy over dx. And as you said, we have 0 on the other side. Now, how many terms do I see? And the answer is 1, 2, 3, 4. Only 2 of those have the variable of interest. This and this. So I'm going to move y cubed to the left, to the right-hand side, and 4xy to the right-hand side. Of course, they will change their sign. And factor out dy over dx from these two terms. So the first term is 3xy squared and plus 2x squared, everything multiplied by dy over dx. On the right-hand side, I have a minus in front, and I have y cubed plus 4xy. Yeah, I put the minus in front, but you don't have to. You can distribute if you want to. I am after this quantity. How do I solve this equation, which is now linear? It's a linear equation in dy over dx. How do I solve it for dy over dx? Divide. So put the minus in front. The top is y cubed plus 4xy and 3xy squared plus 2x squared. And again, yes, if you say it's not a big accomplishment, I would not agree with that, but I would say, yes, you're right. I could not come up with an expression with only x in it. Of course, the function is there. But it's a big accomplishment because in case we want to find the rate of change of this with respect to x for a particular value of x, we will be able to. Okay. So I have 7 minutes. I'd like to use another, or look at another problem, and then we can stop. This section is not finished. I still have to show you the derivatives of inverse trig functions. And then what is left from this section, from this chapter, we have 3.6, which is derivatives of log functions. We do not cover 3.7 in this class. It was done before. 3.8. I meant to say we do not cover 3.8. We cover 3.7. Okay, 3.8 was done. 3.9, related rates. And 3.10, linear approximations and differentials. And 3.11, hyperbolic functions. So it's still a lot. Yes, from chapter 3. Yeah, it's a big chapter. Okay, would you like to choose anything else? I pick?
Yeah.
Okay, so I would like to look at 26 on page 215. And that is sine, in parentheses, x plus y, equals 2x minus 2y. They are giving us an ordered pair, pi comma pi. Use implicit differentiation to find an equation of the tangent line to the curve at the given point. So this is a curve. If I ask you to solve for y, you will say absolutely impossible. We can still determine the equation of the tangent line. We are given a point. I'm going to check my point. So pi plus pi is 2 pi. So this is 0. 2 pi minus 2 pi is 0. That's correct. So the equation of the tangent line will look like this, where this is pi and this is pi and this I don't have. So what do I do now? The answer is implicitly differentiate to find an expression for this, and then plug in pi. Can anyone give us the left-hand side prime? Careful. Very good. So it is cosine of x plus y times, this is a sum, luckily at least it's not a product or a ratio, times the inner function prime 1 plus, very good, awesome, very good, awesome. The right hand side is definitely 2 minus 2 times dy over dx. Very good. Okay, I have now to separate the terms with dy over dx from the rest of the terms, which means I have to distribute cosine. So I have to distribute this quantity to 1 and the same quantity in front of dy over dx first. So this is cosine x plus y plus cosine x plus y multiplied by dy over dx equals 2 minus 2 dy over dx. Now I see two terms having dy over dx. So I'm going to move this term here and this term there, and factor out dy over dx. So cosine x plus y plus 2 dy over dx equals 2 minus cosine x plus y. And now I can find the final expression for dy over dx. And then plug in pi. So we are after this, and what do we write? Two minus cosine x plus y over cosine x plus y plus 2. And now I want when x is pi and y is pi. Okay, how much is pi plus pi? How much is cosine 2 pi? 1. So this is 1. This is 1. The top is 2 minus 1, and the denominator is 3. And now I have everything I need. So I have y minus pi equals 1/3 x minus pi. So y equals 1/3 x minus pi over 3, but plus pi. Pi minus pi over 3 is 2 pi over 3. So I'm going to write it here. Y equals 1/3 x plus 2 pi over 3. This is the equation of the tangent line to the given curve.